So what we were talking about was, instead of generating like this fixed square around the player, we were gonna try and get it to move with the player. Yeah, it's me managing to close that. So what's going on whenever that Firefox closes is that I'm thinking I want to crouch or I want to go down. So I start holding down Control, and I'm still moving forward. So I've also got W held down, and Control W is close tab in Firefox. So lots of fun. There we go. Anyways, so what we kind of want to do is we want to get the camera location and the generation of the coordinates or the chunks to sort of be connected, so that whenever we move, we find the closest chunks and we make sure those are rendered. At least that's my nasty idea. Whether it'll work, I have no clue. And how we're going to do it is also actually an interesting question, which I don't have an answer for right now, but we're going to find out together. Definitely the first thing we're going to want to do is we are going to want to get be able to grab the position of the camera. So vector 3, get position. This is again constant, and I really want to inline this because performance is good. More performance is better. And because it's just grab this variable and return it, it's kind of nice to just inline that so that we don't do a function call just to grab a variable. Great. So we can now do that. Then what we'd like to do is essentially we need to have a list of chunks that should be populated, I think, at least. So right now we're still just gonna have the camera operating global coordinates. Or should we go for the let's keep it in like local coordinates? Thing is, then we are gonna have to take a look at how we use this position. So right now we're adding GLM 3 vectors to it every once in a while. The rotation isn't that bad. I mean, there's a little bit of it where we might want to do so that if it becomes too big, we wrap it back around to the beginning, but yeah, that's a minor thing. At least I'm going to claim it's a minor thing. So yeah, position. What we need to do is probably have the idea of an absolute position combining sort of a chunk coordinate, which is going to be an integer, and then a local position within that chunk, which will be a floating point number. Would at least sort of be my guess. So what I want to do is I want to create a class here. We're going to have it be called absolute position. There we go. So we have the concept of an absolute position here. And we can initialize an absolute position. Well, I don't actually know how we're going to initialize that yet. We'll take a look at that. But an absolute position has essentially two parts. It has a set of integers, which are my chunk X, chunk Y, and chunk Z coordinates. And then it has a couple of floats, which are the coordinates within that chunk. Now to this, we're going to have an operator where we can say, okay, I have an absolute position. Just going to go void here. I want to be able to add a GLM vec3 to that. So this is an offset that we want to apply to it. Also, we want to be able to, as a GLM 3 vector here, we want to be able to get local position. So that's the local position within the current chunk. And as a GLM I vector 3D, so it's an integer vector, we want to get the chunk position. So these are both going to be const. And in fact, we are also going to ask them to be inline here. So what we want to do for the first one is that we are going to return a GLM vector 3 based on our local x, y, and z coordinates. And for the chunk position, we are going to be returning the chunk portion of this as an integer vector. So for our camera, the position here, we are going to place with the concept of having an absolute position. Instead, check to see if that still sort of works. So we have camera is able to get position here. That is going to be the absolute position and not that vector anymore. There we go. So we have no viable overloaded here for the position, which was normally 002. An interesting place to start. I would have guessed we started at 0. But we're just going to default construct that in a moment. And then there's a translate in the camera code where we set up the transformation here. And that's because we are trying to set up a transform based on the position. We want to set it up based on the local position now, so that we keep the camera centered near 0, 0. Yeah, and we get an unresolved symbol here on absolute position, GLMVec3. Something with some precision. I have no idea what we're getting an unresolved symbol on, but there's plenty of stuff that's not implemented. Oh yeah, the ++ operator. So what we want to do is we want to first of all do the constructor. I need to tell it that we have a default constructor here. So we have a default constructor, which should just initialize the various coordinates to 0. So chunk is 0, 0, 0. I am absolutely failing at writing again today. We need a colon there. Then z coordinates 0 as well. X within the chunk is 0. Y within the chunk is 0, and Z within the chunk is 0. Great. So that sort of initializes. Then we also need to do our operator here. And what I think the easiest way to do this is to just essentially start by adding it to our local offset. So we're going to move it by an X amount. Y and Z are also going to get added. And then we are going to have a normalize function. Which is going to be an internal function which we use, which is going to look at the X, Y, and Z coordinates and then modify the chunk coordinates based on those. So what we do is we have a normalize here, which of course is not going to be constant. because it should only be necessary to call from non-const methods. So when we normalize this, what we're going to do is, as long as, this is where it gets interesting, because what I'd like to do is I need to have a sort of bound for this. So when we're working within a chunk, we're going to have 0, 0 being the middle of the chunk. So what we need to do is we need to have a constant expression. Float will probably be more practical. No, I want it as an integer. I want accuracy in this case. Bound being the chunk size halved. So that's 8 at the moment, but that's not the important thing. So as long as x is less than minus bound, and I want another one called step, which is the same as the size, but it makes more sense to do it like this. So if x is less than the bound, what we want to do is we want to add step to x and subtract 1 from the current x, or the chunk x we're in, because that means that x has moved to negative and is into the next chunk. We should move it up to the top and move to a different chunk. We do the same for in the positive direction here. So if x becomes larger than the bound, in this case, we subtract the step and we increment the chunk instead. Same idea goes for y here. So if y, then we need to step the chunk y value, and like that. And if it's the other way, again, I am hitting my keyboard all wrong today, and the chunk y. And finally, z coordinates. There we go. Non-static data member. So it's a static. Let's just see how I declared the size. Static const expression. Same here. Static const expression. We don't need the bound and the step don't change depending on the position. It's always the same. Great. So we can build that. That works. If we just quickly switch over, what we should see is that we can't really move anymore. Or at least when we try to, it's going to sort of do this weird jumping at the top. There we go. So if we move up, it jumps back down because we're only looking at the local coordinate. We're not looking at chunks yet. So we should have this effect in all directions, where we get sort of warped back and forth. And that's sort of the idea of trying to keep the camera centered in the world, or at least the part of the world that we're rendering. So now we need to move the chunks around that. And the way we are going to do that is that when we do our chunk rendering, we have here we get our chunk position. We also need to get this relative to our camera location, which is gonna mean passing in even more fun stuff here. So what I want to do is I want to get, for our render here, in addition to, okay, that was the wrong place I clicked. In addition to all of this fun stuff, I also want to grab a const glm IVEC3, which is our, no, this is our center chunk. There we go. our chunk render here is also going to need to take that, and our get position is going to grab the center chunk here. Now, as we do this, we need to sort of move this in two directions. First of all, our GLES renderable here needs also to know that we're passing this in as well. And it apparently needs to know about that type. That was, yeah, whatever. Interesting matrix or interesting includes, but we'll get to that at some point. In fact, we could probably do it right now. So for the vector, it's actually called vector3, and for the matrix, it is matrix 4x4. Makes it a little bit easier to understand later. Yeah, we've got lots of fun stuff. So for our chunk here, we get the center chunk passed in here. So if we go over for our chunk functions here, this now gets the center chunk as well. Now to do this, what we are going to do is we're not just going to take our x-coordinate, but we're going to subtract the center chunk's x-coordinate so we get our position relative to the center chunk, whatever that may be. So we're going to grab the center chunks x, y, and z coordinates here. That should allow that part to work. Now over in the renderer here, we've got too much, but luckily our renderer has the camera. So we can get our camera here, we can ask for the position, and we can get the chunk position of our camera. So now we should keep keeping our, and my graphics card is not really cooperating today. Hey Talar, right now working on getting sort of the world centered around the player so that we don't get weird artifacts when floating points get really large. Really hoping that's working. So let's give it a go. We're gonna try and reload. With any luck, we should be able to move around in the world again without being forced back and forth whenever we cross a chunk boundary. And that seems to be working. So right now we're essentially, when we're staying within a chunk, we're moving the player. But as soon as we change chunks, we cause the player to jump back, and then we move all the chunks instead. And that way we sort of keep the world centered on the player and allow the player to have sort of the maximum precision around them. And in that way we avoid any artifacts if we like move out until crazy coordinates. And I decided to close Firefox one more time. This is probably going to be a repeating theme all day. So let's just grab that capture again. There we go. So that seems to work. Next on the list, we are going to, well, essentially we're going to make the world infinite now by allowing movement in any direction to sort of expand what we are looking at, so that we don't get these wonderful edges. And I was just about to hit Control W again. So yeah, that is what's happening today. Now, how to do this? Because right now we have a lot of well, right now we're hard coding a lot of stuff like our chunk lists and stuff like that, and cameras and input systems and stuff. What we'd like to do is probably move this into a world class where we can query the world for chunks around this position, and it will then try to find them, and if it doesn't have them, it'll start generating them. Would at least sort of be my guess as to what might be good to do. So we are going to create a world class. Oddly enough, it's going to be called world. So for our world, we're going to have a constructor. At some point, it'll probably take a world seed or something like that. Still need to figure out how to incorporate that, but at some point. What we really want is we want to grab a standard vector, probably a constant standard vector, because we don't really need to know or need to modify it. And I think my graphics card is having a really hard day. There we go. Either that or C-line is. I can't really say. But we're going to include vector here. And we're going to grab a set of chunks here. Reference. Get those chunks. And we're going to base this on a GLM IVEC3 center chunk. Or no, we're going to do it on the complete absolute position. So we're going to take an absolute position here. Const one at that. Yeah, the world is made by two passes of simplex noise. So it's let's see if I can just find the code here. So we do it right here. We have one 2D simplex noise function which generates a height map, and then to add to that we add a little bit of noise to that with a 3D simplex algorithm or pass which has a set cutoff. So that way we sort of generate a nice smooth height map, and then we can add those weird lumps and bumps on top of that with another simplex pass. So where was I? Was doing world stuff here. So this is sort of the center here. And we probably need to include the concept of a chunk. Include chunk. H. There we go. Yeah, it works pretty nice. It's going to be interesting to see how it goes when it gets infinitely. About 2 months, 1 day a week. Didn't get that much done the last month. You can grab all the episodes that I have on YouTube, which ideally should be a link in the description. If not, I should probably just paste one once I find it, because I'm really slow at this. Here we go. There's a link in chat to the YouTube channel. It has about 20 episodes so far of about a half an hour each. So I guess that makes it, I've been working on it for about 10 hours. Well, probably something like 14 right now. Not that long. But I mean, there's a lot of stuff I still want to do with it. So what we want to do is we want to have Chunk's not a variable. Okay, C-line's just confused. So we have a list of current chunks. Which we will populate and do weird stuff with. And then I want to have a static const expression radius squared, because that makes life a lot easier if we square the radius right away. 64. And we're going to do that as a floating point. So this is sort of the area around the player we want to render. So having done that, we are going to create, first of all, if we just have a constructor, does nothing interesting. Might do something interesting at some point. So getting the close chunks to the player is sort of the interesting part. Because what we want to do is we want to, there's two ways we can go at this. We can either recreate all the chunks that we've been doing, or we can either recreate all the chunks every pass, or recreate which chunks it should be and find them, or we can try and maintain a list of the chunks around the player, and then add and subtract from that. And I kind of like the second option, but it's going to be a little bit nasty trying to keep track of what we have and what we don't have. So I'm going to need to think for a little bit. And yeah, I'm pretty impressed myself. I had not expected to get this far in that long or that short of a period. I mean, you can't interact with the world. You can just fly around above it like this. But it's actually rendering something, and it's actually generating a world, which is pretty cool. So yeah, I'm really happy with it. It's gone a lot easier than I was expecting. I was expecting to maybe like spend half a year getting to this point or something like that, with only one day as well. Oh, I code professionally as well. It's not just a hobby. I do game development for a hobby. I code professionally, so that does help it along a little bit. So let's just switch back here. Seems we ran out of music, so let's try and find a little bit of that. We're gonna go here, I think. Anyways, where were we? So yeah, what we have is we have some chunks, which we can get a relative position on. We can then try and figure out how close they are. We can remove the ones we don't want, and we can probably add ones we need. So what I think we should start by doing is we should probably have sort of I don't know if it's insane. I've learned the hard way that sometimes it's better to be relatively it's better to be very pessimistic about how far you're going to get than being optimistic. So that's kind of the way it goes. And go ahead and bug me all you want. It can get a little bit lonely when you don't have that many viewers. So fun answering questions. But anyways, I think what we're going to do is when we start up, we're going to calculate sort of a set of coordinates that are the coordinates we want to render around the player. So we're going to have a set of GLM integer vectors, which will be sort of the I think we'll call it a view sphere, which is the area around the player that we want. And we'll just standard set might be a bad idea. I think we'll go with a vector. That can't be entirely bad. So when we create the world, what we're going to do is we're going to do this the very, very simple way. We're just going to iterate between, or just work our way around. Right now I'm doing radius squared. I don't actually really want to do that much because I also want the actual radius. So we're going to have the radius first at 8. And this is where it gets interesting because I want that as an integer. So we have the radius at 8, and then we're going to have the radius square as radius times radius. Did I say not entirely bad? I have no clue what's going on. I generally forget what I've been talking about after about 30 seconds. Anyways, we're going to run x from radius until it's, as long as it's less than or equal to radius. We're going to step 1 up, and then we're going to do that for all 3 coordinates, because duplicating code is always the best way of writing it. Or wait, no. So x, y, z. Need to work through all of these. So this generates a cube around the player. What we then want to do is to say if x times x plus y times y plus z times z, Pythagoras' theorem is less than or equal to the radius squared, then we are going to actually, given that I'm doing that, I want the radius squared to be, well, I kind of want it as a float, I kind of not want it as a float. So we're going to go with not want it as a float, because that's more precise. So we're going to do that. Once we've got that in, if it's within this, so now it's within the sphere as well, we're going to take our view sphere, and we are going to place back on that, we are going to add x, y, and z as a chunk around the player that we want to render.